Trigonometric identity, communication. Sin x minus cos x plus 1 divided by sin x plus cos x minus 1 is equal to sin x plus 1 divided by cos x. So we need to prove this trigonometric identity. Okay, and while proving, you should specify what exactly you're doing, right? So that's the communication part. Now, let's start with left side, because left side seems to be more complicated and it can be simplified to the right side. That could be one approach, right? But what you see here is we could even start with the right side. So if we start with the right side and we need that on the left side, what we can do is we will multiply and divide by one of these terms. So I'll show you a new approach here. Starting with the right side this time. We'll start with the right side this time. Right side is sin x plus 1 divided by cos x. So contrary to what we had been doing, I'm starting from a simpler side and getting to a complicated side. And this approach also works. I'm just trying to show you that part here. So the right side for us is sin x plus 1 divided by cos x. We want to make it more complicated, correct? To do so, what I'll do is, we want to get this thing in the denominator or that in the numerator. So let's select the denominator. So let's say we want this in the denominator. So I'll put this in denominator. That means I'll multiply both numerator and denominator by this term, which is sin x plus cos x minus 1. So I will multiply also by the same term, minus 1. Now the idea is that I'll just factor this and I will not expand the denominator, because in the denominator I need sin x plus cos x minus 1. And somehow I'll get a factor of cos x in the numerator, which I'll cancel and then get the left side. Let's try to do that. So in the denominator, what we have is cos x times, within bracket, sin x plus cos x minus 1. Now in the numerator, let's expand. So we should get 6 terms, sin x times these 3 and then 1 times these 3. 6 terms, right? So sin x times sin x is sin square x. Sin x times cos x is plus sin x cos x, and then minus sin x. And when I multiply by 1, I get all these 3 terms. So I'll get plus sin x plus cos x minus 1. That's what I get. Now let's see if we can simplify this a bit. So we have denominator as such, which is cos x times sin x plus cos x minus 1, and in the numerator we have one term with sin square x, let's write that, plus sin x cos x, and sin x minus and plus will become 0, so then we have plus cos x minus 1. Okay. Now sin square x can be written as 1 minus cos square x. Then we get cos x common here. So let's do that. So instead of sin square x, I'm writing 1 minus cos square x plus sin x cos x plus cos x minus 1 divided by cos x times sin x plus cos x minus 1. Now 1 minus 1 is 0, and I'm left with minus cos square x plus sin x cos x and plus cos x. So from here, these 3 terms, I can take cos x common, right? So let me take minus cos x common. So if I take minus cos x common, because 1 and 1 cancel out, right? Now minus cos x common, I'm left with cos x here minus sin x, and because I've taken minus, I'm changing the signs, okay, minus 1. So this is what I got. Over cos x times sin x plus cos x minus 1. Now, well, I could have taken plus cos x because I need reverse signs. That's good. Okay, doesn't matter. So cos x and cos x cancel out. And in fact, I'll multiply back with minus because I'm seeing minus for cos and plus for sin. So it makes sense, right? I'll just multiply. So the idea here is the common factors cos x will cancel out, right? There, you know, minus 1 and 1 got cancelled out. Then we took cos square x, cos x minus common. Now I'll multiply by minus back and I'll get minus of cos x plus sin x plus 1 divided by sin x plus cos x minus 1, right? Now this term is same as this. I just need to rewrite it. So let me rewrite this sin x first, right? So we have sin x minus cos x plus 1 divided by sin x plus cos x minus 1. So do you see how we got to the left side, which was actually a complicated side? So at times what you can do is you can start from a simpler side and make it more complicated, right? See the way we made it, right? And it does work at times, correct? Thank you.